Now we're going to discuss the math portion for figuring out drip rates. So if you could pull out your handout that has the picture on the front of it, and I've given you the formula right up here. So it's dose ordered in mLs times your drip factor over time in minutes. So I'll rewrite that out here. Now to abbreviate that, I'm just going to put dose ordered times your drip factor over time in minutes. So looking at this first problem at the bottom of the paper here, and I'll read it all out since the text is pretty small. Your patient requires 250 mLs of normal saline, NS is just an abbreviation for normal saline, over 2 hours. You have a 10 drop per ml administration set. How many drops per minute will you administer? So looking, and I want to fill in all of my different things that I need here. My dose ordered, I want to give my patient 250 mLs. So my dose ordered will be 250. My drip factor, I have a 10 drop per ml administration set. So my drip factor will be 10. My time, I want to give it over 2 hours. So we have to convert that to minutes. So 2 times 60 is 120, so it'll be 120 minutes. So what I equal out with is 250 times 10 over 120. Now I can simplify this a little bit. I can take a 0, if I have a 0 at the end of a number, I can take a 0 off the top as long as I can take a 0 off the bottom. It has to equal out top and bottom for me to be able to do that, and that makes my math a little bit easier. So now I'm left with 250 times 1, which is just 250 over 12. Now when we're doing these problems, we want to get our answer to the whole number. Because we're giving drops per minute, we cannot give a fraction of a drop. So I only need to find my answer to 1 decimal place so I can round my answer to the nearest whole number. So 12 goes into 25 2 times. Then my 0. 12 cannot go into 10. Now remember, to round to the nearest whole number, I do need to find it to the nearest decimal place, to the 10th. 12 goes into 100. Well, I know that 10 goes into 100 10 times, so I'm going to try 9 to see what I get. So that's going to be too much, so now I'll try 8. That works out. Now I can stop here since I'm rounding to the nearest whole number. So I'd round this answer to 21. So my drops per minute, I would write 21. GTT is abbreviation for drops. So my patient requires 250 mLs of normal saline over 2 hours. I have a 10 drop per ml administration set. How many drops per minute will I administer? I will administer 21 drops per minute. All right, here's some examples. Number 1, my patient requires 1,000 milliliters over 4 hours. I have a 15 drop per ml administration set. How many drops per minute will I administer? So my dose ordered, I want to give 1,000 mLs. My drip factor, I have a 15 drop per ml administration set. My time is 4 hours, so I do need to change that to minutes. So 4 times 60 is 240. I'm just plugging these numbers into the equation because remember it's dose ordered times drip factor over time. I have a 0 at the end here and a 0 at the end here, so I can reduce it a little bit to make my math a little easier. 15 times 100 is going to equal 1500 over 24. (24) into 150, because I cannot do 24 into 15. Well, I know that 25 goes into 156 times, so it's probably going to be 6. (24) goes into 62 times. Now I need to find my answer to 1 decimal place so I can round to the nearest whole number since I have a remainder. 24 goes into 120. Well, I know that 25 goes into 125 5 times, so I'm going to try 5. 5 times 4 is 20, it's 10, and it equals 120 even. So I have 62.5. I need to round that to the nearest whole number, so I'm going to round that to 63. Make sure you label your answer with the drops per minute. If you cannot remember the GTT, then you can just write out drops per minute. So my patient will get 63 drops per minute, so they can get that 1,000 mLs over 4 hours using that 15 drop per ml administration set. My second one here, always write out your equation. It's the best way to memorize it. And I'm just going to write out each of my values. My dose ordered. My patient needs 2 liters of fluid. So 2 liters is 2,000 mLs, because remember we want this in ml since our drip factor is in ml. My drip factor here is a 20 drop per ml administration set. My time is 2 hours. We need to convert that to minutes, so 2 hours would equal 120 minutes. Now I'm just going to plug in my numbers from this equation. I'm going to take a 0 off the top, and I can take a 0 off the bottom. So now I have 2,000 times 2, which is 4,000, over 12. (12) goes into 40 3 times, which is 36. (12) goes into 40 3 times again. You can see I'm going to have a repeating number here. So for this patient, I'm going to round this to the nearest whole number. This patient is going to get 333 drops per minute, which would pretty much just be running that fluid wide open. Next question. My patient requires 20 mLs of normal saline over 15 minutes. I have a 10 drop per ml administration set. How many drops per minute will I administer? Let me write out my equation. And then I'll just write out all of my values. My dose ordered, I want to give 20 mLs. My drip factor, I have a 10 drop per ml administration set. And my time is already in minutes. It's going to be 15 minutes. So now I'm just going to plug these numbers into that equation. 20 times 15, oops, 20 times 10 over 15. 20 times 10 is 200. So I have 200 over 15. 15 goes into 20 one time. 15 goes into 50 3 times. Now remember, you need to find it to one decimal place so you can round to the nearest whole number. 15 goes into 50 3 times. So for this patient, where I want to give 20 mLs of normal saline over 15 minutes, and my administration set is a 10 drop per ml administration set, I would give 13 drops per minute. Okay, my last question. My patient requires 250 milliliters over 4 hours. This is kind of cut off. I have a 60 drop per ml administration set, so this one I'm going to be using my micro administration set. How many drops per minute will I administer? So first write out your equation and then write out all your values. My dose ordered, I want to give 250 mLs. My drip factor, since it's my micro set, it's going to be 60 drops per ml. And my time is 4 hours, so we need to convert that to minute. So 4 times 60 is 240. Now I'm going to put those numbers into my equation. I can take off a 0 off the top and a 0 off the bottom to make it a little easier. 250 times 6 over 24. 6 times 0, 0. 6 times 5 is 30. 6 times 2 is 12, plus 3 is 1,500. So I have 1,500 over 24. 24 cannot go into 15, but 24 can go into 150. And I know that 25 goes into 150 6 times, and since 24 is less than that, I know it'll probably be 6. Twenty-four goes into 60 twice. Since I have a remainder, I need to find it one decimal place so I can round to the nearest whole number. 24 goes into 120. Since this 24 times 6 is 144, we'll try 5. And it equals 120. So for this patient, to give 250 mLs over 4 hours using my micro tubing, I'm going to round this to the nearest whole number, so they're going to get 63 drops per minute.